is Professor Dr. Nielsen. He's the CEO and the Director of Software Engineering Institute of the Carnegie Mellon University. For some of the long timer of the ER conference, you probably remember he's also attended the bigger talk at in Brazil, that's ER 209. Then later, 2 years ago in Hong Kong, he also gave an excellent speech there. We are very honored to have him. Now, he has the very rare combination talent in the area we like to have. One is the technology, the other is military applications, and also the practical applications. He has a PhD from UC Davis and an MBA from the University of New Mexico. So a very distinguished career in the Air Force. At the last position he had was the commander of the whole Air Force research laboratories, United States Air Force. Now I have the honor to meet with him at the so-called United States Air Force Advisory Board. And I think also at that time, Nick Lutari here, also a consultant there. So we are very honored to have that. And right now, he also serves on the United States Defense Science Board. That's considered of all the defense, not just the Air Force, but also Navy, Army, everything. So he has very broad spectrum. What's happening both in terms of government military applications and also the practical application. Now for the Software Engineering Institute, it's something funded by the United States Department of Defense because about probably 30 years ago, right, the Department of Defense realized the software is one of the most important things in all the operations. So they set up a license to the Carnegie Mellon University to set up an institute concentrated on software engineering. So there are several famous research being developed there. One is CMMI, to different stages of software development. So right now the institute, because Dr. Nielsen's leadership started 11 years ago, and so right now build up very strong two components. One is software development, software research. The other one is cyber security research. Also, there are several things very important I'd like to mention is today's talk will be talking about the challenges of building and testing of increasing autonomous systems. Many of us probably are aware of the importance of things become more and more atomic. Okay? And one thing I think probably in Europe, I think it's happening in the United States recently, people are talking about self-driving cars, okay? Self-driving car. Okay? And you probably heard about the announcement like Google, like Apple. Apple make an announcement, say starting 2019, about 14 years from now, they are going to have a product of self-driving cars. Okay? And so people are getting excited, but on the other hand, there's a big problem. I think Dr. Nielsen is going to talk about that, is the trust. How can we trust them? Because when I talk to my wife, and she said, okay, self-driving car will hit somebody, or maybe get myself killed. Okay? So there's a lot of issues involved. So I think we are very honored to have him come in today to talk about all the issues. And also, he's very familiar with the ER community. So he can also tell us, give us some suggestions, what kind of thing we can do in this area, okay, to help the community, to help the whole world. Okay, let's welcome Dr. Nielsen.
Thanks. Well, that was a longer introduction than I expected. It's one of those where you say, gosh, I wish my mom and dad could have heard that. Thank you, Peter. That was maybe more than you should have said. So I'm very happy to be here and to be back with the ER community. I did make it here twice before to talk to the ER community, once as it was mentioned in Gramado, Brazil, which was very nice, and then 2 years ago in Hong Kong. I've been able to come to Stockholm 3 times before, but it's been 12 years since I've been here, so it's been a long time. And this area, Stockholm, Kista, has grown so much with so many companies and everything. The last 3 times I came, I was still in the Air Force at the time. And 2 times I came to work with the Swedish Air Force on a couple of projects. One was on foliage penetrating radar, and the other was on ground collision avoidance software to protect pilots from flying themselves into the ground, which happens sometimes, unfortunately. And the 3rd time I came to a real special thing. In 2001, it was the 75th anniversary of the Swedish Air Force. It's the 2nd oldest Air Force in the world. The only one older is the British, the RAF. And so they had a wonderful event with people from Air Forces all around the world to kind of help celebrate. So I like being here, and I'm of Danish descent, so you see my last name ends in S-E-N. When I come to Sweden, I get teased about that a lot, because the Danes and the Swedes and the Norwegians do tease each other sometimes. Every now and then, if I go into a store and they see my last name, they start talking to me in Swedish. I have to slow them down a little bit. So today I'm going to talk about increasingly autonomous systems. And we choose that title, which is a little awkward title, kind of carefully. As Peter mentioned, I just served, I was the co-chair of a Defense Science Board study on autonomy. And one of the arguments that most people who talk about autonomy get into is, when is something really autonomous? And sometimes people think the only thing that's autonomous is so devoid of any connection to people that it just does what it wants and doesn't do what we want. We found that talking about degrees of autonomy or what's fully autonomous versus what isn't, maybe isn't productive. And that the real thing we're seeing right now is a large trend to devices, systems that are increasingly incorporating some autonomous features. When you think about it, and we'll see some examples, this march to autonomy is happening quickly and accelerating right now. So let's go to the next slide if we could. So once upon a time, computers were people. It was largely women that would do this tedious job of adding up big things and multiplying things and creating logarithmic tables. And because they were computing, in the old days, they were called computers. Now, if you go next slide, now we build these computers, and that reminds me of my first IBM PC. Boy, I thought it was a great computer. It had, I think, 64K of memory in it. And boy, I just thought, how would I ever use that up? And I quickly learned how to use it up. Now computers tend to operate themselves, and if you click this again, this is a little video from Amazon's warehouse. And these are a system designed by Kiva to help automate their warehouse. The warehouse is huge. It's almost a square mile. And they used to have pickers that would go around there to fill people's orders. But they found that individuals who were doing this were walking 15 to 20 miles a day. And they could do that for about 3 months and they'd get worn out and quit. And so they developed this system where it's not fully autonomous, but these little micro robots go underneath shelves and bring the shelves to the pickers. They could automate that. What they're still having trouble with is the grasping function. It's one thing to move a shelf. It's another thing to know that an egg has to be picked up one way, a barbell another way. And so they haven't quite figured that out yet. So they still have humans doing the picking. Let's go next slide. So some autonomous systems might also be software-intense systems. When we talk about autonomy, many people rush to UAVs and self-driving cars. And in our Defense Science Board study, we talked about that as autonomy in motion. But there's also autonomy at rest, because there's systems that are doing a lot of thinking and programming and sometimes even acting with cyber-physical systems, but they themselves don't have a physical presence. And here's the other ones that are really real, whether they're airplanes, self-driving cars, robots like Chimp, underwater UAVs, underwater vehicles, these little micro UAVs. How many people have seen a quadcopter or a micro UAV in use today? Most people here have probably seen those, right? I think in the United States, at the end of 2014, there were 500,000 of these little hobbyist UAVs around. And I was in my office the other day briefing somebody, a visitor we had, and all of a sudden outside my window was one of those, just kind of hovering there right outside my window. Now, it was good for my ego to think somebody wanted to look at me, but they were actually looking at the cathedral on the other side of the street and taking pictures of it. Because a lot of photographers now are using these around the world to take great pictures from interesting angles, etc. Okay? Let's go next slide. Smart machines are more than just automated. They're starting to have autonomous features on them as well. And we can go next slide. And they're more than just virtual reality devices. We're starting to see quasi-robotic systems like this that sort of bring a presence into a meeting, into a building, that help you interact with people who maybe aren't quite there. Next slide. There you go. So these autonomous systems that we're seeing today are really the result of a convergence of 20 to 35 years worth of research that is sort of miraculously all coming together at one time. So work in machine vision has really made some advances right now. And a lot of the self-driving cars are taking great advantage of that. Work in machine learning is really revolutionizing the approach that we're taking to autonomy. We used to think that we had a program in the rules, but now we're understanding that the rules are so complex that maybe it's better to have the machines learn the rules from practice. And this is really changing the way autonomy is being implemented. Natural user interfaces are really changing. You know, our original interfaces with computers were with punch cards and then through the keyboard. But so many advances have been made in speaking to computers, in computers understanding our gestures, that our interfaces to computers are changing to become much more natural type interfaces, just as if we were talking to a crowd here. And of course, underneath all that are these tremendous algorithms that have been developed over time, and a whole advanced state of sensors that are coming, miniaturized sensors that are changing. In your smartphone, there's an amazing number of sensors in that smartphone that help with so many things, from accelerometers to things that understand whether it's up or down, to things that can tell whether you're stepping or not. There's so many sensors, and the sensor world has gotten so cheap that we can implement these wonderful sensors in tremendous ways. Next slide. And of course, there's been a lot of improved software practices. And this is very important because these systems are very complex and very large. And so it's important that we have good architectural insights into the systems and that we build these large systems with a quality, because they're so large, that they don't have too many defects inside of them. Next slide. And so we're going to talk about the convergence of software capabilities. You can hit that again. So in 2007, this was one of the Carnegie Mellon entrants into what was called the DARPA Urban Challenge. Now, they had the first challenge where they were doing off-road work, a little safer to do, and singly. This challenge in 2007 was in an urban area with cars driving around, with stop signs, with all those things, and people had to drive. But if you look at the difference between the 2007 car, with its rack of sensors, I mean, it really looks like a laboratory prototype. And here's a 2014 self-driving car, which looks just like a car. Things have come so far in a few years. When DARPA started that challenge back around 2004 and 5, it was thought that it was a real stretch goal to have a car drive in an urban environment and not cause accidents. And now you know that we're all starting to accept this, looking forward to this, and thinking about when this will become a reality. I was in Kyoto, Japan about 3 weeks ago at a conference on science and technology and society. And Prime Minister Abe was there. And he said that he thinks he's the first head of state to drive in a self-driving car, because he's driven in a self-driving car around Tokyo. And he said that the Tokyo Olympics in 2020, his goal is to have all the visitors and guests there move around the city in self-driving cars. And I thought that was a little bit of a stretch goal until the speaker after him was a deputy prime minister from Russia. And he said, oh, and by the way, the World Cup is going to be in Russia in 2018, 2 years before the Tokyo Olympics. And we're going to have self-driving cars take care of all the guests in Russia at the World Games, at the World Cup. I don't know if it's a little bravado, but self-driving cars are going to come. And as we have a little teaser, before we get into self-driving cars, we're going to have to trust them. We're going to have a lot of trust. Let's go next slide. So we're going to go through these quick, so double quick on this. So autonomous systems have been around for a while in some state, and they've improved a lot of productivity. Many factories, especially repeatable and precision type motions, have been done by autonomous systems. The integrated circuit world would not have come along without autonomous systems. We wouldn't have been able to get the precision. Next slide, and hit it again. One thing they do is they can operate continuously, 24 hours a day. This is something that no matter how dedicated a person is, they can't do. You know, they can't operate 24 hours a day and without losing attention and losing sleep. Next slide. These systems are changing the way we get information around the world. And we now collect so much information around the world, all of us. Maybe we collect more information than we know what to do with, but lots of information being collected about us all the time. Next slide. Autonomous systems can handle volume far beyond what a human can handle. So there's certain applications that almost demand autonomy. And one of those is sort of in cybersecurity, where the volume of attacks is too fast, too much for a person to handle by themselves. So increasingly we're having autonomous systems take care of cybersecurity. Next slide, double hit. Also, autonomous systems go where people really can't go. We already saw space, but they can also go into really dangerous situations. They can rescue people from fires. They could go into Fukushima, where nobody wanted to go because of the radiation hazard. So there's reasons why we're looking at increasing autonomous systems. Next slide. Next. And of course, some of the things we've sent out to explore the universe. And right now, Curiosity on Mars is a very autonomous system, although it does send information back and can be reprogrammed and controlled from Earth. It actually does much of its mission autonomously because of the time delays and everything to have a signal reach Mars. Next slide. So one thing we're starting to notice, though, is that the relationship between machines and people is starting to change. For a while, we were acting cooperatively. Sometimes now, we're almost getting codependent. And one thing ethicists and others worry about is, will we become competitive with machines? Next slide. Our systems are increasingly autonomous. 2020. Algorithmically driven agents will participate in 5% of all economic transactions. 20% of business will be authored by machines. 6 billion connected things will be requesting support. 50% of the fastest companies will have fewer employees than instances of smart machines. More than 3 million workers globally might be supervised by robo-bosses. Now, you might not like your boss now, but what about a robo-boss? That could be pretty demanding, right? Next slide. Autonomy is also big business. So right now, in 2014, $6.2 billion on autonomous systems around the world. In 2019, they're projecting $15 billion. Hit the slide. By 2021, 1 million Internet of Things devices will be purchased and installed per hour. Now, right now, I think in 2013, there were about 9 billion things connected to the Internet. And with the Internet of Things coming, people are saying by 2020, 50 billion devices may be connected to the Internet by 2020. 50 billion. Next slide. One concern that's out there is economic disruption. This digital workforce, I mean really the digital workforce, not us, they're going to be lower costs and maybe easier to train on certain kinds of tasks. Next slide. Autonomous systems do those tedious, time-consuming tasks sometimes better than us. Our attention wanders. It's hard for us to watch something that doesn't change for a long time. We like to see change. An autonomous system can watch and watch and watch for hours, for years, and then the tech change. Next slide. They can also perform very specialized tasks extremely well. Surgeries, unmanned passenger jets. Are you ready to get on one of those? I believe in technology. I'm not quite ready to get onto a jet that has no pilots. You know, I get on elevators that don't have operators. I even get on trams to go to the airport that sometimes don't have an operator. I'm not ready to get on the airplane that has no operator yet. Next slide. So one view is that this new digital workforce of autonomous systems will eliminate human jobs. And that's got a lot of people afraid. Gartner predicts that 1 in 3 jobs will be converted to software, robots, and smart machines by 2025. Not that far away. New digital businesses require less labor. Machines will make sense of data faster. Some jobs that may be lost: pharmacists, lawyers, paralegals, drivers, astronauts, store clerks. It's all the jobs. Think about that. Almost all the jobs that we know today have a chance of migrating, at least in some measure, to more autonomous systems. Next slide. But there's an alternate view that maybe the digital workforce will actually create human jobs. That it will free us up to do different things, higher level things. But that's something still that's a worry for everybody. Next slide. Another concern is the ethics of autonomy. And this is a real big one. Okay? So can we give autonomous systems an ethical framework within which to work? Here's a big task that's related to trust. We do tasks, and we know how to accomplish tasks. And we're actually pretty good at maybe assigning this to autonomous systems. But when we do tasks, we do them within a bigger framework of ethics and morals and what's right and wrong. I don't know that we know how to give machines that bigger framework yet of what's right and wrong. We teach this to our children. You know, our children are born and they don't necessarily know right from wrong, but we spend years training them on, you know, this is the way to behave, this isn't, no, even though I told you to do this, you should have been more polite when you did it, you know, all those sort of rules. How do we teach robots to be polite? They're very task-oriented. When we start to think of that in things like conflict, in law enforcement, will robots take their job too literally? Will they be too specific? Will they have a heart when they do their job? Will they do their job with a brain that understands the context in which they work? And ultimately, you know, you think of London where there's one closed-circuit TV camera for every 11 people. How will autonomous systems start to affect our privacy and our civil rights? These are big issues that have to be thought. But while we're thinking about them, the technology is racing ahead, almost faster than we can actually understand these sort of ethical, societal issues. Next slide. So can an autonomous system choose the greater good? Suppose you're driving in an autonomous system and you're not, you know, sitting there reading your book and enjoying the view, and all of a sudden the car senses a ball going into its lane. And you as a human would know maybe there's a little boy or girl coming out to get that ball. And at the same time it sees that, it sees a semi-truck drifting over into its lane. How is the autonomous system going to decide what to do? Each of us, you know, would have to decide that in an instant. And it would be a tough choice, right? It would be a bad choice. But how would the autonomous system decide? Next slide. The next generation of algorithmic-driven financial agents are going to be fully autonomous. We've already seen what that can do. I think something like 90% of the trades on Wall Street are by robo-investors right now. And we've seen some bad effects of that with the flash crash that occurred a few years ago, where all of a sudden, you know, some down prices could trigger more down prices, and a lot of stock is being dumped onto the stock exchange at one point in time, leading to a large large decrease in stock's value. That was kind of an artificial thing. We don't want that. We want to have stable financial systems just like we want to have stable societal systems. Next slide. New concern, already mentioned the personal drone ownership. You know, you can buy a drone for as little as $300 US dollars. Photographers are buying them all over the place. The most popular drone is available from Alibaba. It's made in China. That's the one that in the United States alone, they've sold 500,000 of those small drones for photographers and hobbyists. And there's 10,000 of those being ordered a month in the United States right now from Alibaba. Next slide. So some predict that autonomy actually will pose an existential threat, a threat to our existence. And these aren't people you can completely discount. Steve Wozniak, you know, the partner of Steve Jobs and Apple, computers are going to take over from humans, no question. If we build these devices to take care of everything for us, eventually they'll think faster than us, and they'll get rid of the slow humans. Elon Musk, you know, he was kind of big in eBay, then now he's run SpaceX and Tesla. Hope we're not just the biological bootloader for digital superintelligence. Unfortunately, that is increasingly probable. He's also said that AI is like summoning the demon. Stephen Hawking, the development of full artificial intelligence could spell the end of the human race. This is pretty grim. This is very dire, right? Next slide. But others say autonomy will enhance and extend our lives. Ray Kurzweil, he's been an advocate for robots and autonomy for quite some time. By 2029, computers will be able to do all the things that humans do. We're going to use these tools to make ourselves more expressive, more intelligent, more high-end. By 2030, we'll be putting millions of nanobots even inside of our bodies to take care of diseases, to build up our immune system, to kind of keep us healthy. These are two pretty divergent views, right? One very dark, one very bright. Where's the truth going to be? Next slide. Here's an individual colorblind from birth that's become a little bit of a cyborg. He has a sensor that kind of gives him different tones to let him know different colors he's watching. And he says this has allowed him to dream in color now. Next slide. So how do we build trust? Trust is at the heart of all this. We can't send systems out that are going to perform badly. We don't want to send systems out that have no ethical basis, that have no moral compass. How are we going to build trust? This is a big issue. To me, it's not so different than the way we train people, including our own children. You know, we don't initially trust our child to maybe play outside by themselves. We teach them some rules, we observe them, ultimately we start to get comfortable with it, and we let them play outside. All of us as parents, when we first start to teach our child how to drive, we certainly don't trust them right now. We take some time, we train them, we observe them, we build confidence, ultimately we send people out as teenagers and young adults to drive. I think a lot of the issues that we're going to have with machines, we can draw parallels to people. In a military sense, we bring people in, we train them. Just like people in a job do, we train them. And ultimately, we build trust that they can do that task. But even more importantly, ultimately, we want to train them in a way that they can work as teams with other people, that they can work as teams within a big organization, and that they have that context and situational awareness to make the right decisions at the right times. Again, how are we going to get that into these autonomous machines? How are we going to build trust? Next slide. So the thing that's holding autonomy back, even as it rushes forward, is this whole idea of trust. Next slide. One way we build trust is through familiarity. I mentioned that elevator operator. When I was a little boy, every elevator had a person in there to bring it from floor to floor. When they first stopped doing that, there were a lot of people that weren't happy about that. They felt very afraid. But now nobody thinks twice of getting on the elevator that operates by itself, that operates autonomously. Similar for the trains and subways that sometimes work autonomously. We will start to trust when we become more familiar with these autonomous systems. The fact that we're starting to see these autonomous drones used by hobbyists will start to build our trust. But for systems that have potentially more lethal effect, like an auto-driving car or an airplane, we're going to have a long time to build that trust. Next slide. So quality. It's very important in a software engineering sense that we build in quality. These systems are so large that if we do a bad job of developing them, they're going to have so many defects that we're never going to have trust. So from a software engineering viewpoint, we have to architect them well, and we have to build them with the right kind of quality in it so they don't have many defects. Next slide. We have to understand that these systems are going to evolve. And so that puts some different things on, different importance on the whole thing of trust. Some of these systems today are not deterministic systems. We think of systems that we think of if-then kind of computation, if this, do that. But we're getting to systems now that are more non-deterministic, that look at probabilistic assessments, just as we do, on what's right and wrong, what to do next. When Watson won Jeopardy! It received information from natural language interfaces, and then it had to quickly decide on what was the best possible answer. And lots of times, there's so much ambiguity in natural language and the way we speak, that it wasn't always completely sure. And so it would look at things, and sometimes it would have a 70% answer and a 30% answer. And it would give the 70% answer, and most of the time that was right. So we're going to see things that are more statistically based and more non-deterministically based. In addition, one of the keys for autonomy now is to build systems that are based on deep machine learning. And if we do that, then these systems will never be quite the same. They will evolve with time. I learned a new word today. I think they'll be pendurant. Is that the right word instead of endurant? So they will change in time, each step of the way. And so if they're changing in time, how will you test them to build trust? This is a tough thing for us to think. Next slide. We have to think about vulnerability discovery and analysis. These are large software systems. How will we make sure that they have the right amount of cybersecurity on them unless we really test them and try to break them? So to build trust, we're going to have to do that. And all of you have seen, as we go to self-driving cars, you've seen how today's cars have often been hacked. And you can exploit the brake system, exploit the drive system, you can turn the car on or off. The same thing with your cell phones. Right? Anybody has a cell phone with a camera in it, that can be hacked, and someone can turn that camera on when you don't know it's on. Okay? Next slide. And maybe most importantly, because we're probably going to step into this more autonomous world with team between humans and machines. So how are these human and machine teams going to work together? In most cases, our first step won't be to allow a system to be fully autonomous. We're going to try to take advantage of what the machine can do and what a human can do. Because right now, only the human can put that context in, can put that moral guide in. How are these systems going to work together? In the most recent DARPA challenge, they had humanoid-type robots that had to do 8 tasks. They had to get into a vehicle and drive a vehicle, get out of the vehicle, walk through a door, pick up a bandsaw, saw a hole in the wall, go over to another place, turn a dial to open up a water flow, go through another place where there are obstacles, walk around it, and then ultimately go through a final door and go up some stairs. Okay? These are all humanoid robots. There were 28 teams entered. 3 teams completed all the tasks. But these were robots that actually had a comm link to a person. They didn't have a lot of bandwidth, but they did have people in the link to help them. And so this teaming between human and machine really helped. By the way, in that contest, there were international teams, and the team that won was from KAIST, from South Korea, the Korean Advanced Institute of Science and Technology. 2 U.S. teams came in second and third, and then there were lots of teams from all over the world that came in elsewhere. Let's go to my final slide. This is my final slide, but it sums up some of the things I think are important. We need to recognize that autonomous functionality is increasing in almost everything we do, from your cell phone to the tunnelbana to the pendeltag. Everything's getting more autonomous. Trust, in all of its manifestations, is going to be a central concern before we really transition. Okay? And I think this community of conceptual modeling, of enterprise relationships, and entity relationships, can really make a contribution here. Because right now, it's all complex. And I think some aspects of conceptual modeling may get at the roots of where we have to establish trust and where we can establish trust. One point in establishing trust is to know when you can't have trust. When would it be inappropriate to have trust? And therefore, we should not use that, or we have to take delegated powers back. I believe the entity, the ER community, the conceptual modeling community can really help us on understanding both how to build trust and how to find the limits to trust. And then I also believe when we look at this model of people and machines working together, and it's a complex thing, but I think this is another place where the conceptual modeling community can make a major contribution and maybe help put the ethics in and the context in that a straight engineering approach, with just what can we do, might not be able to do. So I think this community has a really central role in where we're going with autonomy today. So that's all I have for you today with thanks, tak, danke, merci, whatever your nation is. Thank you so much for listening to me today and for inviting me back to this wonderful conference. I feel like a young person. I know when you look at me, you go, he's not a young person. I don't feel young in the mornings either when I get up. But I feel like a young person because young people are always looking to learn. And I'm still eager to learn new things. And that's one reason I come here, because I'm certainly a novice in this community. But I love listening to the conversations and learning a new way to look at a problem, a new tool that you can use to solve some of the problems that we have. Thank you very much.
Okay. We have some quick questions. Anybody?
Sometimes quick questions don't have quick answers.
Anybody? Any questions? Okay.
Here's a question, a brave soul.
No?
Give me the mic so I can speak.
Thanks for the talk. It was very, very, very interesting. So this is an unusual message where you're in some sense exhorting this community to look at AI more carefully, which we sometimes do and we sometimes don't. One particular aspect of AI that I thought sort of came out of your talk was, and this has a lot to do with trust, is this notion of adjustable autonomy. The idea that while we are talking about autonomy as a single atomic abstraction, it actually is a finer grained beast, and possibly the kinds of things we do in this community in representing knowledge, again AI notion, might be the best way to understand this notion of adjustable autonomy. So I thought I'll put that to you as something that you could dwell on a bit more.
Yeah, and I have one extra. Yeah, that's a good point, and that was one of the points I was trying to make. In addition to the fact that there are steps along the spectrum of autonomy, one thing we've learned now is that in many systems, the amount of autonomy we give to a system will be dynamically delegated. It won't always have the same autonomy. We want to be able to control that. And in certain situations, we might be willing to let the system run free, but in other situations, maybe not. When we were doing the study, we had some nice presentations from many companies around the world. And I think it's Rolls-Royce that's working on autonomous cargo ships for the oceans. Okay? I mean, huge ships. In many of these cases, those ships that used to have hundreds of people on now have 12 or so. They want to get it down to 0. But although they're willing to let them go through the high seas, maybe with no people on it, when they come to a port, you're going to take back that authority and have people on it to bring it into a port, right? So I think there's other examples where we will want to dynamically delegate autonomy and delegated responsibilities based on the situation. Good question, good comment.
Because we are short of time, so we will stop here. But let me just say something. Dr. Nielsen he will stay here for 2 days. So this evening and also tomorrow dinner banquet. So there's plenty of opportunity. You can ask him. He's also good in not only the high-level perspective, but also the technology. He's a 2 fellow, IEEE fellow, and an AIAA fellow, as well as U.S. National Academy Engineering. So you can ask him the technical questions too.
But I'm not going to stand right here.
Okay, sure. Let me just represent the conference. We can have a gift to you.
Great.
Yeah. This is the automated system.
I like that.